So I'd like to start off by acknowledging that although perhaps there shouldn't be, there is still a quote unquote controversy surrounding climate change. What would you tell people here who are still either on the fence or doubting? What is the most compelling evidence proving that climate change is real and that humans have accelerated it?
Well, Mark, if I was in any other country in the world, I would not get that question. And in fact, as far as scientists that are studying climate change, you've heard the 97% that are fully in agreement that, one, that climate change is happening, and two, that it is from human activity, especially burning fossil fuels. Even those studies about the 97% have been reconfirmed by the National Academy of Sciences. If you look at the Intergovernmental Panel of Climate Change of the UN, that represents the best climate centers in the world. And most recently, they have shown that with very high confidence, again, climate change is happening, and it's from burning fossil fuels and cutting the rainforests, the CO2 sink. So I would say to someone, look, number one, I'm a health scientist working with climate scientists, and even if I was a climatologist, I'd say, go to the IPCC and look at the evidence that they show. Those are, most of the climate scientists working on this. And just Friday, the U.S. National Assessment on Climate Change was released, again confirming that they are unable to find any alternative evidence for climate change other than burning fossil fuels. So there's no scientific debate. And that's the key thing. It's not a scientific debate anymore. There are many non-scientists. This questioning comes from non-scientists that think we're still in the days where we use punch cards and the largest computer drive is a 40 megabyte drive. We have come a long way, and the climate scientists are more and more certain about it.
If you track their predictions too, aren't we arriving at a lot of those predictions earlier than even they had expected?
That's the other key message, is that climate change is not off in the future. We are already seeing an increase in the frequency of extreme events. As the sea surface temperature is warming, we are seeing more frequent Category 4 and 5 hurricanes. Not necessarily more hitting landfall, but when storms form, they're stronger. The climate scientists say it's hard to pin blame attribution on climate change of any single event, but the mega fire in California that destroyed 7,000 houses, you talk to the climate fire modelers and they say, well, that's consistent with extremes of the water cycle. More flooding and buildup of fuel, and then extreme drought, that's consistent. The heat wave in Europe that killed over 50,000 people in 11 days, you can't blame that on climate change, but the climate scientists say the probability of that event happening has been increased by 5 to 10-fold for the current greenhouse gases in the atmosphere. So the probabilities are increasing. We are seeing these happening now.
Now, you brought up a number of the things that people are most familiar with as consequences of climate change: rising sea levels, also increasing heat. But infectious diseases and their effect on infectious diseases, I think, get less attention. So can you tell us, why does climate change affect infectious diseases? How does it affect?
Sure, yeah. Yeah, and now one reason that I've been studying this myself for more than 20 years is because when you look at those physical attributes of climate change, rising temperatures, sea level rise, extremes of the hydrologic cycle, the water cycle, so more extreme droughts, floods, and fires, all of those affect health through multiple pathways, certainly directly through heat waves, air quality, malnutrition, forced environmental refugees. But the infectious disease aspect is because of the sensitivity, the climate sensitivity of many diseases. Let me ask the audience a question. You know, what's the difference between us mammals and insects, besides the fact that we don't fly? And Dave reassured me that most all of you don't suck blood. So, I mean, we are warm-blooded. Our body temperature is always more or less the same. An insect, a mosquito that could carry diseases, that's called a cold-blooded animal. Reptiles and insects are cold-blooded. So whatever the air temperature is, that's the body temperature of the mosquito. And if that mosquito, let's say it's Aedes aegypti mosquito that carries yellow fever, dengue fever, and Zika virus, if the temperature goes up, the viral replication rate goes up, and mosquito and biting rates go up. So that when we think about the difference between winter and summer temperatures in Wisconsin, and we say, well, what's 1 degree? Who cares about 1 or 2 degrees? It's really important in these biologic systems that involve insect vectors, the insect vectors that carry diseases. So I've seen some explanations of climate change that the greatest threat may be the smallest,
right.
And they're talking about insect-borne diseases.
Yeah, hasn't I believe the Asian tiger mosquito is one of the examples people go to again and again. In I think 30 years, hasn't it spread like enormously? I mean, to parts of Europe where I think it hadn't been in Europe at all 30 years ago. Let's look more at zoonotic diseases, and what does climate change do to animals in general in terms of their location? What happens?
Yeah, well, so with climate change, of course, you're going to be shifting habitats, and that could mean the movement of reservoir hosts or intermediate hosts that carry disease, as well as their vectors. So take, for example, the Lone Star tick has been identified as moving northward into Wisconsin, as one example. The range of the Asian tiger mosquito, Aedes albopictus, which can overwinter, that's been heading north. So there has been documentation of in the northern hemisphere, northward movement of some of these vectors. But of course, climate change should not be viewed in isolation. What we do to the landscape is very important as well, so that we need to be thinking about land use change and ecological change, how that may shift biodiversity or may change, for example, for Lyme disease. If you ask me what's more important, land use or climate change, I'd say it's really complicated in a 2-year cycle, and I'd say probably land use change, but that's a really tough question.
When we talk about land use changes, give us some examples.
Well, I'll give you one example that's not from here, which is something that we studied in the Peruvian Amazon, where we found a direct relationship between the increased risk of malaria with deforestation. Controlling for human population density, we were able to show that the increased frequency of biting of the particular Anopheles darlingi mosquito that carries malaria in that region increased with deforestation. We're not exactly sure why that happens. There are some ecological explanations. It may be with the aquatic ecosystem and temporary pools of water rather than established biodiverse, rich pools of water where there are lots of things that eat mosquito larvae. We're not exactly sure, but we found relationships between deforestation and malaria risk.
I was fascinated by something that you mentioned to me in an email. You said that it's not just the movements of animals, but it's human migration too that's affected by climate change. That we don't hear as much about, but I think you mentioned Syria.
Yeah, so this is a really important point. I'm always asked, will we see more of these diseases move into the United States? The first thing is that many of the mosquitoes that carry dengue fever and Zika virus, they're already here. The mosquitoes are here. It's a matter of human population movement bringing the virus. So it's really important to look at these different aspects. You need both the insect vector, but it's already here, but you also need population movement. Now, Syria is interesting because, to be honest with you, when we look at any single disease related to climate change, I think it's a very fragmented, narrow focus when you say, well, what's more important? Climate's influence on that disease or some other influence on that disease. And I would say the issue about climate change is it's not a single exposure, dose response thing. And that some of the indirect effects of climate change could be the most drastic. Now, Syria. A paper published in the Proceedings of the National Academy of Sciences showed that just before the Syrian civil war, they experienced the worst drought in the instrumental record. Rural to urban migration rates were documented to be 4 or 5 times higher than normal. There were food price shocks and people rioting in the streets. So these types of destabilizing situations, extreme climatic situations that then put a strain on natural resources and food supplies, I think that those are very scary. Impossible to study, to disentangle, that drought effect versus political strife. The same thing happened in North Korea during the famine. Was it the famine, was it the drought, or was it the inflexibility of the North Korean government? They're very tricky. But this is what sort of keeps me up at night when we think about how big these indirect effects of a changing climate regime could be.
I mean, all of a sudden, I'm imagining as you're talking that a resource that we so take for granted, water, could be, the source of, war between countries, basically, if we begin experiencing shortages of it, something that most of us here in this country have never, have not experienced, although California had its drought a couple of years ago.
Right. I'm going to use your bringing up water to add on another thing about infectious diseases, because the most sensitive diseases to climate change are vector-borne diseases, mostly insect and rodent, but mostly insect-borne diseases, and waterborne diseases because of more flooding and contamination. When I co-chaired the first national assessment on climate change, this report to Congress, the sleeper issue, the one that we had no idea was a big problem, was waterborne diseases. In fact, the United States, I think we're a relatively developed country. We can't handle our stormwater very well today. Today, more than 1 trillion gallons of sewage-contaminated stormwater overflows into our lakes and rivers every year.
Wow.
That keep Niagara Falls running for 18 days. And Milwaukee, of course, is a unique place. That cryptosporidiosis epidemic that happened in 1993.
Didn't that have a possible climate component too?
Well, we analyzed that as having the highest precipitation month in the 50-year record that we studied. Now, I was just this morning with Dr. Sandra McClellan, who's at the School of Freshwater Sciences at University of Wisconsin-Milwaukee. And they're monitoring for pathogens in the water. And every time it rains in this area, there are millions of gallons of sewage-contaminated water that comes through the system. And it's one reason why Milwaukee pushed its water intake 1 mile out further into Lake Michigan, because these waterborne diseases, they're a big problem. And with failing infrastructure underground, as far as the drinking water and sewage, this is another really important infectious disease problem.
Is it possible that we see some of these, both waterborne and vector-borne diseases, that, here in the U.S. that we haven't seen in, maybe half a century? Things like, yellow fever. We see malaria very, very rarely. Are those things that doctors are going to have to be prepared to, diagnose in patients?
Well, that's a really tough question, and I think that the way I've been asked that before, and I think that it's impossible to predict whether or not we will see malaria, other than travel-related or airport malaria and things like that. I don't know that it will become established, but what I do know is that the risk will increase, because these are tropical diseases. Malaria cannot develop inside the mosquito unless it's above 15 or 16 degrees centigrade. That's why it's a tropical disease. It's got to have warm enough temperatures. So as temperatures warm across the United States, the risk of these diseases will go up. I think what will happen is we will end up paying more money.
Wow.
And we'll have to, do more to prevent these diseases. So whether or not we'll see more cases depends on our response, and I think that you showed that in your video. I think it will be costing us more.
Can you just quickly, you mentioned airport malaria. Can you explain to people what that is?
Well, we're in a globalized world, so these pathogens can be anywhere in the world in 24 hours in an infected person flying around the world. So one study we did 10 years ago showed that the countries most immediately affected by climate change would be the poor countries that have lots of malnutrition, malaria, diarrheal disease. Yet we're in a globalized world, so an increase in disease anywhere with international travel can show up. And so what you have is someone infected with malaria may land in Miami, and there are mosquitoes that can carry that, and there may be a few cases, once you have, and the parasite shows up, if there are mosquitoes that can pick up the blood and carry it to somebody else, you can have a few cases, but that's airport malaria as opposed to really getting a full-blown
Doesn't it also
epidemic.
involve, can't you get malaria-carrying mosquitoes from other countries that just happen to be aboard a plane or in a shipment or something like that end up at the airport?
Well, I'll go back to the story of West Nile virus, which, based on the genetic fingerprinting of the virus, it looks like it came from the Middle East. It's unknown how it got here. People theorize that it could have been infected mosquitoes in the cargo area, in the cargo hold of the jet. In theory, an immunocompromised person, but it's really unknown how it got here. But interesting, when you couple international travel and climate, I don't say anything. The climate change had nothing to do with West Nile getting here. Looks like it was jet travel. But when it arrived in 1999, in July, that was the hottest July ever recorded in New York City. And the American strain of West Nile virus is much more tolerant and, in fact, likes hot temperatures more than the European and African strains. So this is where these dangerous synergies happen, I think.
Sounds kind of like a 1-2 punch. If it arrives at a place where it can establish itself, and temperature is a very important part of disease. So if the temperature is warming and a mosquito arrives from another place, it can at least be here long enough to pass on a disease. Go ahead.
I'll just finish. So I'll make two things. One, also as West Nile traveled across the United States, mostly from birds, bird migratory pathways. Bill Reisen, who's a arbovirologist, mosquito-borne virus person, pointed out that the hot spots of transmission were literally hot spots.
Wow.
So when West Nile showed up in the Midwest in 2001 and 2002, predicted to be moving across the country because of the birds. But the places with the most transmission were unseasonably hot. Same thing in the Rockies and in California. So there was a synergy that, yes, it's moving across because of the birds, but the hot spots. And finally, Zika virus. Zika arrived in Brazil. You can track it, it came from the Zika forest in Uganda, 1947, right? You know the history more than me. Coming across the ocean, and then they picked it up in Tahiti. Well, however it got to Brazil, and people speculate either a canoe tournament or the World Cup, international travel is involved, but guess when we had record temperatures across Colombia and Brazil? It was that 2015 El Nino, the strongest in recent history. We've done the climate analysis, and the temperatures were 5 standard deviations above normal, a 50-year record that we looked at. So did that have something to do with it? We're looking at the biology of Aedes aegypti mosquito. Another paper in the Proceedings of the Academy of Sciences came out showing that right before Zika erupted, the climate-related biological vectorial capacity for transmission of Zika and dengue fever were the highest in the last 60 years.
Wow. So this is the point at which I got to ask you for a little bit of hope. Let's talk about some of the things that would be effective ways to prepare or to deal with this. I mean, I've read a lot of the literature that talks about that maybe thermal screening that's done at some of the airports isn't going to be the solution. Are there things that we as a country can do to at least prepare and maybe prevent this sort of spread of infectious diseases?
Right. Well, there are several things to do at different levels. And of course, in public health, you want to go as far upstream as possible. As far as prevention, I think that the first thing would be to have really good early warning systems for climate. Mm-hmm. So to the extent that we understand the relationships between extreme climate conditions and disease, we should have great early warning systems for climatic conditions. At the same time, we have been not funding general surveillance for these diseases. So we need to set up these mosquito sentinel sites where they have cages of chickens, and they take blood from the chickens every week to see if the chickens have virus or not. So setting up these sentinel chickens for surveillance, I think, is really important. And then, you can also think about, you don't always want to be mopping up the mess while you don't try to turn off the faucet. And I think this is where there also needs to be attention to what's causing the disruption of the Earth's climate. Mm-hmm. And of course, that's going way upstream and trying to reduce our fossil fuel emissions.
Going back to the concept of trying to have better surveillance, you were talking about. In terms of that, we're not talking just about surveillance in the U.S., right? I mean, we would be talking about having surveillance in, far and wide, right, in other countries.
I think that our best national security in terms of infectious diseases is investment in poor countries all over the world where a lot of these diseases are emerging from. So if we're thinking about, yes, let's just wait till it hits our border and let's put up sentinel things, in the U.S., that would not be wise. We absolutely, I think that you raise a really good point, that we need to be thinking strategically about where are the hot spots, and like the wet markets in China and places around the world that where you've got bushmeat hunting and things like that. Absolutely, we need to be moving further upstream, which means out of our country, and looking at where you have these hot spots of transmission. So, for sure.
Great. Now looks like it might be a good time to take some questions. Anybody? We'll get a mic to you.
Here? All right. There it is. Okay.
Can I give a few instructions? If you're in the lower bowl, raise your hand and we can call on you. When you speak, hit the rim of that little brown thing there and hold it down while you speak. And then we have microphones in the back that are mobile, so take it away.
Yeah, they're really cool microphones.
Right. Okay. In about 2014, I think the authors are Ansolabera and Konzicki, I hope I have their names correct, wrote a book called Cheap and Clean. And they took a look at trends in public opinion in the United States toward fossil fuels and alternative fuels, and also global climate change. And what's interesting in particular about this presentation today is one thing that they recommended is in terms of getting public understanding and sympathy for moving away from fossil fuels and taking a look at alternative sources, is to emphasize the health effects of fossil fuels, both directly and indirectly, through global climate change, is perhaps a better strategy to use than what apparently is now is probably a more diverse kind of approach to it.
Yes, I think this is where we get into talking more about chronic diseases rather than infectious diseases. And I say that because when you think about burning fossil fuels that create greenhouse gases that warm the climate, when you burn oil, coal, and gas, you also emit dirty pollutants like PM 2.5, sulfur dioxide, and the other dangerous pollutants that harm us immediately. According to the Global Burden of Disease and the World Health Organization, 7 million people die every year prematurely from air pollution. According to the World Bank, air pollution costs the world economy more than 5 trillion gallons? More than $5 trillion every year. So, there are immediate health benefits if you were to reduce fossil fuel emissions as a climate change policy, but you have an immediate health benefit. And it's, the argument is, I've seen studies that ask what would it cost to invest in clean energy, like with renewable energy that might be more expensive. Forgetting about subsidies for coal and oil and whatever, forget subsidies, that's a whole other can of worms. But this study showed that, well, it might cost up to $30 for every ton of CO2 that you don't emit from investing in clean energy. But for every ton of CO2 that you don't emit, you're also not emitting the dirty particles and other things that hurt people, such that there'd be a health benefit on average of $200 in avoided mortality and hospitalization. So, decision makers are saying, oh, we don't want to pay the extra money for clean energy, and they're completely ignoring the bigger half of the equation, that if you got to cleaner energy, you would save lots of money and you'd save lots of illness and mortality. The EPA looked at this when they passed the Clean Air Act. They've been required to ask investment costs versus health and environmental benefit. And it's been about $1 investment leads to $30 in benefit. It's the same thing, immediate benefit from fossil fuel reduction.
Wow. There was, I think, another question around here. Yes, please.
obviously, when you talk about putting money into surveillance, I assume you're talking, well, prior to this last election? And I'm wondering where you see surveillance funding in other countries going under the new president. And then if you push back, if the feds don't do it and the international community can't pick it all up and it falls to the borders, you know, America first, what's the best steps and what do states and localities have to do? That's really just one question wrapped up in
Mark, you're the Pulitzer Prize winner.
Well, what I try to do is break things up by parts, because I don't have a big enough brain to take the whole bit. So let's start with the first part. You were
direction now that, you know, I assume the surveillance was inadequately funded under President Obama and his predecessors. Now you have an administration that doesn't want to fund much of anything outside the borders. But
I would have thought that especially after Ebola, SARS, H1N1, I mean, weren't there bumps in funding for surveillance? I mean, do you remember there being any? I know that at the moment, I mean, Ebola we all know how that dominated the headlines. It was a huge, quote unquote, crisis. And I think if you'd asked people in the middle of that, they would have thrown billions, trillions at it.
Until you get Zika virus that then needed more money, that didn't get more money but took money from Ebola. So I think that this is where I hope that we don't have to just be chasing these disasters and crises and be completely reactionary. I think it's really worth reminding the current administration that it's about national security, that infectious disease outbreaks come from all over the world, and the idea that the zoonotic diseases that are most of the emerging infectious diseases come from all over. You know, it's a matter of reframing, I think. I'd have to talk to a good journalist and talk about reframing the issue as a national security threat, and maybe it would get more funding.
Well, the other thing that it strikes me as kind of a pay me now or pay me later kind of equation, because that money in surveillance, if we don't spend it then and we have an outbreak, we spend a lot more money responding to a disaster like that. I mean, it's comparable to a situation like the wildfires in California. If we don't spend, you know, money on one end, you know, we end up spending a ton on another. I mean, I think for H1N1, if I remember correctly, I think it was in the order of something like $7 billion or something that we spent on, you know, responding to that outbreak. That's a huge amount of money. I would guess that would have gone a long way in terms of surveillance. Just one thing, when we go back to, you were talking about some of the poorer countries. Many of us may not have a solid idea of just how, just what their medical, sort of their health infrastructure is like. Just how far, you know, behind us or you know, can you give us sort of a picture of more what they are dealing with?
Well, you know, it's a sad situation that you go to Africa and almost everyone has a cell phone, but they don't have sewage treatment. They don't have clean drinking water. There are places all over the world still are lagging way behind in public health infrastructure. So, you know, we have made progress. You know, there are many diseases we're close to eradicating polio. Let's cross your fingers that extreme hydrologic extremes and more rainfall and more stormwater sewage doesn't make it more challenging to get rid of polio, which it will, but we're almost there. You know, we have reduced malaria. We've made many great gains, but lacking infrastructure, especially in public health, is still, it's a shame that we cannot move faster as far as public health infrastructure.
Any other questions?
Hi, my name is Dr. Joseph Bionanebye. I'm a clinical assistant professor in the Department of Biomedical Sciences here at Marquette. And I was born in Uganda. I was part of the National Outbreaks Task Force that responded to Ebola and anthrax 2010-2012. I want, first of all, say a word of appreciation. There is a lot of work that is being done out there in the developing world. It's about CDC, it's about USAID in predicting and responding to those diseases. We must first appreciate. So my question to you, some of the climate adaptation strategies that we are talking about seem to be macro at a higher level. What can we do at a lower level as individuals, as students, as people who are interested in publishing information? Because I feel like everything's at a higher level, you know? Maybe you could give some thought.
So thank you for asking that excellent question. And the way you prefaced your first part of that question, I think, is the answer, which is that, in fact, we have much more to learn from developing countries and how they deal with day-to-day and annual crises, especially around climate adaptation. You know, we have more to learn from countries under stress and dealing with these disasters than we actually understand. So there has to be a very healthy bidirectional flow of information, number one. And, that's where, and also tapping into traditional knowledge. And I mean, Native American, First Nations, and traditional knowledge around the world is something where people have been living with the environment and having a closer relationship to the environment than many of us in the industrialized world. And I think there are lessons there, major lessons. So it's got to be a very bidirectional engagement. We'll have the most learning. And the adaptation strategies are all, there are many of them, they're all over the place. Number one, though, is that we need to bridge the divide between ministries and different sectors. That's one of the most important things that can happen anywhere in the world, including our own country, that the Ministry of Environment is talking with the Ministry of Finance, which is talking to the Ministry of Health, and not fighting over the same financial resources. That, in fact, you take one step forward in development, and if you're too narrow in your development, you've just caused more problems than you've solved, right? So it's got to be a much better coordinated approach. And there's something very important in the World Health Organization they've been pushing, which is called a health in all policies approach, to make sure that all sectors are involved. When you design a neighborhood or design a city, be in touch with people working in health and environment, and in water and sewage, and recognize that if you build impervious surfaces, you're going to worsen your stormwater, or you're going to worsen your urban heat island effect, or you're going to design cities for motorized vehicles and design daily exercise out of existence, So, this health in all policies approach is another important way.
Any other questions? Anybody? Yes.
Oh, okay.
Hi, I'm a member of the Citizens Climate Lobby, which is a nonpartisan group trying to reduce the amount of fossil fuels, trying to contact Congress about getting onto solutions, and there is now in the House a caucus group, which when we started out about a year or so ago, there were only 14 members. The caucus has to be bipartisan, one Democrat, one Republican. At this year, there are 60 members, and they're trying to work on a carbon tax or fee and dividend. And what we can do is we can contact our Congress people and tell them to get on board to this committee. And they better do it fast, because we need that kind of activity. We were just at a conference with a professor from the University of Chicago who told a story about how London, and when you mentioned the Great Lakes, our Lake Michigan and sewage being dumped, well, she mentioned that in London, a couple of centuries ago, they had so much human waste that the Thames River, it was going down the Thames, and the Thames River had 3 feet of this stuff on the side. So she said they had to figure something out. Well, she said carbon is our current waste, and we've got to figure out how to do this. So that's all I have to say.
Let me make a comment about that. It's a good point. And think about, when did smoking rates in youth, when did we have a fall in smoking rates? It was when we put a higher price on cigarettes. Very well documented. And what a lot of people don't understand is that climate change is a public health crisis. It's not just about the polar bears. It is, for many reasons, it is a public health crisis. So like tobacco, there needs to be a price on carbon. And unfortunately, just like the tobacco industry, there is a lot of disinformation abound all over that is trying to sow doubt on the climate science, which is why we need great journalists and all the students, that are going to help counter that disinformation campaign. That's your job now.
You, as you were talking, I was just wondering,
Mark, we have time for about 30 more seconds. Yeah.
Okay, real quick question. Are there any examples of countries that have made this leap, have gone beyond denial, and are now in a transformative stage doing some of the things that would help?
I will shift your question to say not just countries, but places. And right now, with our current administration, by the way, we can't officially pull out of Paris until 2020. But yeah, so even if the international talks stall and national talks stall, we don't have much progress, it's at the cities and the subnational levels that people are racing forward. Like Jerry Brown has organized the R20, regional, subnational regions, moving forward on a low carbon economy. C40 cities, Michael Bloomberg and others, cities are moving forward. So it's time to really pivot to local leadership. And I'd say we need to be vigilant and have concern at the national level, but not get too hung up and realize that the rest of even industry is moving forward to a low carbon economy.
Thank you.
I want to thank Dr. Patz and Mark for the great discussion.